Parallel universes. The idea that our reality is just one of countless others existing alongside us, invisible and unreachable. For most of human history, we believed our universe was everything, the totality of existence. But what if everything we can see, everything we've ever known, is just one bubble in an endless cosmic ocean? Stand outside on a clear night and look up at the stars. That vast expanse stretching 93 billion light-years across might not be alone. This question has haunted physicists for decades, and the answers they're uncovering are far stranger than anything science fiction ever imagined. The concept of parallel universes isn't some fringe theory cooked up by eccentric scientists. It emerges naturally from our most respected physics equations. When Einstein developed general relativity, he opened a door he never intended to walk through. When quantum physicists started probing the subatomic world, they stumbled into possibilities that defied common sense. Today, serious researchers at institutions like MIT, Oxford, and CERN are grappling with evidence suggesting our universe might be just one of countless others. There are actually several different types of parallel universes, each arising from different branches of physics. The first type is almost mundane by comparison. If space goes on forever, and we have good reason to think it does, then eventually every possible arrangement of matter must repeat. Somewhere out there, infinitely far away, there's another Earth, another you reading these exact words. The math is straightforward, but the implications are staggering. Then there's the quantum multiverse, which gets seriously weird. Every time a quantum particle faces a choice, like whether to spin up or down, the universe splits. In one universe it spins up, in another it spins down. Both outcomes happen, just in different realities. Physicist Hugh Everett proposed this in 1957, and while it sounds insane, it actually solves some of quantum mechanics' biggest paradoxes. Every decision you've ever made, every coin flip, every random event has spawned new universes where different outcomes occurred. Right now, there are versions of you who made different choices, took different paths, lived completely different lives. The third type comes from inflation theory, which explains how our universe expanded moments after the Big Bang. If inflation happened here, it's probably happening elsewhere, creating bubble universes with potentially different physical laws, different forces, different constants. Some might have no stars, others might be nothing but black holes. We just happen to exist in one where the conditions allow for life. If you're starting to feel like reality is far more mysterious than you ever imagined, hit subscribe because we're going even deeper into the rabbit hole. String theory pushes the parallel universe concept into dimensions we can't even perceive. The mathematics requires at least 10 dimensions for the theory to work, but we only experience 4. Where are the others? They might be curled up so small we can't detect them, or they might be separated from us in something called the bulk. Our entire universe could be a 3-dimensional membrane floating in higher dimensional space, with other membrane universes drifting nearby. If 2 of these brains collided, it might trigger a Big Bang, creating a new universe. Some physicists think this is actually happening constantly throughout the multiverse. Here's where things get really mind-bending. We might never be able to prove other universes exist because by definition, we can't observe them directly. They're causally disconnected from us. Light from those universes will never reach us. No signal can cross the boundary. Yet cosmologists are looking for indirect evidence. They're studying the cosmic microwave background radiation, the afterglow of the Big Bang, searching for bruises or cold spots that might indicate our universe bumped into another one shortly after its birth. The European Space Agency's Planck satellite has mapped this radiation in unprecedented detail, and there are some anomalies that don't fit standard models. Could they be scars from collisions with neighboring universes? The jury's still out, but the data is tantalizing. Philosophers have argued for years about whether parallel universes are even science if we can't test them, but that's changing. Some versions of multiverse theory make testable predictions about particle physics and cosmology. The many worlds interpretation of quantum mechanics predicts different probability distributions than other interpretations, which could potentially be measured in extremely precise experiments. If we discover that certain physical constants are fine-tuned in ways that suggest they were selected from a larger landscape of possibilities, that would support the multiverse concept. The implications go beyond physics. If parallel universes exist, what does that mean for free will, for identity, for the nature of reality itself? There might be universes where you became an astronaut, a musician, or never existed at all. Universes where dinosaurs never went extinct, where Earth never formed, where the laws of physics are so different that matter as we know it can't exist. The honest answer to whether our universe is truly alone is that we don't know yet. But the question has moved from philosophy to physics. We have mathematical frameworks, testable predictions, and actual data to analyze. Subscribe now to stay with us as we continue exploring the deepest mysteries of existence and the growing evidence that reality is far stranger and more magnificent than we ever dared imagine.